Hello everyone, my name is Stephen Gigrich, and this is my video lab report on Lab 1 Charged Tape. As an overview of my lab report, I'll first introduce the lab and the physical principles behind it, as well as my lab setup. Then I will go over my lab procedures, observations, and calculations. I will then show you my glow strip simulation, and I'll end it off by answering 2 questions of the main ideas of the lab. Introduction. Background information and physical principles. Vectors are widely used in physics to convey multi-dimensional information and consist of a magnitude and direction of a quantity. Coulomb's law states that an electric force is proportional to the charges of 2 particles and the distance between them squared. This is multiplied by Coulomb's constant, which is approximately 9 times 10 to the 9th Newton meter squared divided by Coulomb squared. The electric field theory states that charged particles emit fields into space that can exert forces on other charged particles. And gravitation is a property of matter to be attracted to other matter. This force is easily described by Newton's second law, F equals ma, where A is replaced by G. The purpose of this lab experiment was to enable a better understanding of the interactions of charged particles and point charge approximations of objects. It also increased my proficiency in glow script. Here's my lab setup and some gathered data during the experiment. As you can see, for tape A and B, the lengths were 16.9 centimeters, width 1.9 centimeters, and the mass was 0.169 grams. The distance between the tapes at the time of flotation was 3 millimeters. Some initial results and observations from my experiment were that U-tapes are positively charged. As the tape was attracted to the clear plastic water bottle, I negatively charged by rubbing over my clothes. Other observations are that like charges repel while opposite charges attract, and also that the electric field force is significantly stronger than the gravitational field force. As, for example, the charged tape was able to float on top of the other charged tape, counteracting the gravitational force. Lab procedures and results. To set up the experiment, I first pulled out 2 identical lengths of tape and measured and recorded their lengths and widths, and based on the area, I could calculate their mass. Then I made tabs in both tapes and placed them on top of the table. Rapidly pulling the tapes off the table gave them a charge, and I placed one tape across a gap of books. I then placed the other tape below, bringing it up until the upper tape began to float. I then measured and recorded the distance between the 2 tapes. Some additional observations during my experiment were that both negatively and positively charged objects are attracted to neutral objects. Also, the attractive force between the tape and my hand was surprisingly strong, easily beating gravity. Here are some of my calculations. Using the surface density of the tape and the area of the tape, I was able to calculate its mass, 0.169 grams. Using F equals mg, I was able to calculate the magnitude of the gravitational force to 1.66 times 10 to the negative 3 newtons. Since the floating tape was in equilibrium, the electric force had to equal the gravitational force, and was therefore also 1.66 times 10 to the negative 3 newtons. Continuing with the fact that tape B was in equilibrium, Fg equals Fe, and replacing these, mg equals Coulomb's constant times q squared divided by d squared. Rearranging for q and plugging in, we can solve that the charge of tape B was 7.434 times 10 to the negative 10 coulombs. Using the charge of the tape and dividing by the charge of a single electron, we were able to find how many electrons were on the tape, 4.64 times 10 to the 9. Using the area of the tape and the area of an atom, we were also able to find how many atoms were in the tape, 3.04 times 10 to the 17. One assumption during the atom calculation was that the tape was only 1 atom thick. Otherwise, we would have had to deal with volumetric density of an atom instead of surface density. For some final calculations, I determined the ratio of electrons to atoms, and calculated that it was 1 to 1.5 times 10 to the 8. GlowScript program results. Here is a portion of my GlowScript code and some of the functions I used to determine the electric field, gravitational force, and electric force. Here's the output of my GlowScript code, where you can see the green arrows representing the electric force and the orange arrows representing the gravitational force. You can also see how the code calculated the same charge on the tapes at 7.434 times 10 to the negative 10 coulombs. Questions and answers. For some assumptions, the assumption to ignore air resistance was not needed because tape B was in equilibrium and therefore is not moving. It was useful to treat the long tape as a point charge, however, as it simplified a lot of the calculations. It also simplified the calculations by assuming that each tape had the same amount of charge due to the conservation of charge. If electrons had positive charge and protons had negative charge, it would make no difference in my observations, as it would just be like switching left and right. The positive and negative charges are purely made up and are just a convention. When handling charged objects, it is essential to touch them as little as possible, as every touch transfers some charge from the tape to your hands. Only touching the tapes on the ends will help reduce this transfer.